Now let's discuss about integer in computers. An integer is a datum of integral data type and a data type that represents some range of mathematical integers, commonly represented in a computer as a group of binary digits or bits. Integral data may be of different sizes and may or may not be allowed contain negative values. Integers are commonly represented in a computer as a group of binary digits. The sizes of the grouping varies, so the set of the integer sizes available varies between different types of computer. The computer hardware nearly always provides a way to represent a process's register or memory address as an integer. Value and representation. The value of an item with an integral type is the mathematical integer that it corresponds to. Integral type may be unsigned or signed. Signed means it is capable of representing negative integers, while unsigned means capable of representing only non-negative integers. An integer value is typically specified in the source code of a program as a sequence of digits optionally prefixed with positive and negative. The internal representation of this datum is the way the value is stored in the computer's memory. Unlike mathematical integers, a typical datum is a computer but has some minimal and maximal possible value. The most common representation of a positive integer is a string of bits using binary numeral system. An integral type with n bit can encode n 2 to the power of n numbers. For example, an unsigned type typically represents the non-negative values 0 through 2 to the power of n minus 1. Other encodings of integral integer value to bit pattern are sometimes used, for example, binary coded decimal or the gray code, or as printed characters such as the ASCII. Bytes and octets. The term byte initially meant the smallest addressable unit of memory. In the past, -5, 6, 7, 8, and 9-bit bytes have all been used. There have also been computers that could address individual bits, or that could only address 16 to 32-bit quantities. The term byte was usually not used at all in connection with bit and word addresses machines. The term octet always refers to an 8-bit quantity. It is mostly used in the field of computer networking, where computers with different bytes width might have to communicate. Words. The term words is used for a small group of bits that is handled simultaneously by processors of a particular architecture. The size of a word is the CPU specific. Since it is architectural, the size of a word is usually set by the first CPU in a family, rather than the characteristic of a later compatible CPU. The meaning of terms derived from words such as long word, double word, quad word, and half word also varies with the CPU and OS. Practically all new desktop processors are capable of using 64-bit words, though embedded processors with 8 and 16-bit word size are still common. The 36-bit word length was commonly in the early days of the computer. One important cost of non-portability of software is the correct assumptions that all computers have the same word size and computers have by computer used by the programmer. Given the same clock rate, adding a 16-bit number will not be faster in a computer with 32-bit registers than one with 16 bits, but a 24-bit number will be. The 16-bit computer requires additional steps. 16 bits first, then the remaining 8, whereas all 24 bits of the number can fit in the 32-bit register. Short integer and long integer. A short integer can represent a whole number that may take less storage while having a smaller range compared with a standard integer on the same machine. In C, it is denoted by short. It is required to be at least 16 bits and it's often smaller than a standard integer, but it is not required. A long integer can be represent a whole integer whose range is greater than or equal to that of a standard integer on the same machine. Short integer has 2 bytes while the long integer takes up 4 bytes. So that's all. Thank you for listening.